Happy Wednesday, everybody. I just wanted to give you guys a brief overview. A brief review on the Pythagorean theorem, and then we're going to talk a little bit about the converse of the Pythagorean theorem to help us classify triangles by their angles. In other words, we can use the Pythagorean theorem to tell if a triangle is right, obtuse, or acute. I know for some of you guys this will be a review. For some of you guys this will be brand new, but either way it's going to be essential to our study of trigonometry, which we're going to start on Thursday, tomorrow. So without further ado, let's get into the notes. Guys, in terms of the notes, remember this is a video, and so if you need to pause for a moment and so you can get down some of the side notes, or like if I'm going too fast, please make sure you're utilizing that particular feature of video notes. So let's get right into it. Let's first talk about the Pythagorean theorem and just remind ourselves what it is, and let's work some examples to make sure you remember what the Pythagorean theorem is all about. Remember, the Pythagorean theorem applies only to right triangles. Okay, and so no matter how you see it used today, please understand Pythagorean theorem will help us find missing sides of right triangles. The only catch is you're going to need two of the three sides to find the remaining one. As you can see in the examples down here, if we have two of the sides, we can always find the third one no matter where it is, but also understand the feature is right triangles. As you can see, a right angle in each one. In terms of the formula, this is no surprise. You know it's going to be a squared plus b squared equals c squared. That comes with some special conditions though. If you're talking about a squared, b squared, and c squared, the a and b, it doesn't actually matter which they are, but they have to be the two smaller sides adjacent to the right angle. When I'm talking about the term adjacent, I'm just talking about the term touching. Adjacent means to touch. Like if two desks are adjacent to one another, they're right next to one another, hence they're touching. If two rooms are adjacent to one another, they're sharing a common wall, hence they're technically touching. And so if I'm saying they're adjacent to the right angle, if you look at this example down here, the right angle is here. 40 and 30 touch the right angle. X does not touch the right angle. Hence 40 and 30 are adjacent to the right angle. Same thing on example 2. Here we have the right angle. So adjacent to it should be X and 10 because those touch the right angle. 22 is opposite or not touching the right angle. In example 3, here we have the right angle, and so 6 is adjacent to it because it touches. X is adjacent to it because it touches, and then 16 is opposite. Now, the term adjacent doesn't only apply to right angles, it applies to really anything in mathematics, but in this application, if we're talking adjacent, we're talking touching. The C has to be what we call the hypotenuse. The way we actually find the hypotenuse, yes, it's the largest side in a right triangle, but the hypotenuse is opposite the right angle. What I mean by opposite is non-touching, and so if I had the right angle here, I say X is opposite that side because X is not touching that angle. 22 is a hypotenuse, not because it's only the longest side, because it's opposite the right angle, it's not touching it. And then 16 in this case is also the hypotenuse because again, it's not touching the right triangle or the right angle. And so it's a little bit deeper than just saying, hey, it's the longest side. It really has to do with angles. And that's the thought that I want in your head as you're going through this unit, that a lot has to do with the positions relative to the angles and not just how long the sides are. Okay, now with that being said, we can jump into some examples. Let's just solve for X in each of these three cases. Okay, and so a squared plus b squared equals c squared. Okay, so let me write that formula down first. A squared plus b squared equals c squared. The picking of A and B doesn't much matter as long as they're the two adjacent sides, the two legs. Okay, we also call these things legs. So 40 squared plus 30 squared. We know that the order doesn't matter because of addition. In terms of addition, the order never matters. So it could be 30 squared plus 40 squared, or 40 squared plus 30 squared. What's important is that we have the x squared in the C position because it's the side opposite the right angle. Okay? Now from here, it's just academic. We have to solve this thing down. So if you have a calculator handy, or maybe you can do it in your head, 40 squared is 40 times 40. I believe that's 1600, but it's going to be 1600 here. 30 squared, that should be 900, but let's check it. Yep, 900. Okay, okay, is equal to x squared. Now, in terms of order of operation, you don't want to square root yet. You want to combine the addition. 1600 plus 900 gives me 2500. Okay, the last step, if I want to get rid of that square, I need to square root, which leaves me with an x value of precisely 50. Okay, and it's just as easy as that. And so like the two biggest places we can definitely make a mistake is misordering or not picking the correct values for A, B, and C. And then the second most common mistake is like not square rooting at the right time. Okay, let's work example 2. A squared plus B squared equals C squared. Again, the big potential mistake we can make here is not picking the right values for A, B, and C. Keep in mind, A and B have to be touching the right angle, have to be adjacent to the right angle. And so that means we have x squared plus 10 squared. And that's going to equal the C value, which is the opposite of the right angle, and so that's going to be 22 squared. Okay, and so don't make that mistake of picking the wrong numbers or always assuming the x is a hypotenuse value. That just isn't the case. A, B, and C can appear anywhere on the triangle. So a little bit of simplifying. 10 squared is 100. I don't know 22 squared in my head, so 22 times 22 gives me 484. And now it's just an issue of getting x by itself. So we'll subtract off that 100. Okay, and so x squared should be equal to 384. Okay, so to get rid of that square, we have to square root. Okay, and so the x value in this case, 384, take the square root of that. It's going to be a decimal number. It's going to be 19.596. And since we're rounding it off, we'll approximate the value and make it give it that approximate sign. Okay. Now this number makes sense to me because x, the hypotenuse does have to be the largest side in the triangle, and of course we have the x value that's less than, and so that's not a bad guess. Of course we can feed that back in the Pythagorean theorem to make sure it fits. Take 19.596 squared plus 10 squared, and sure enough that's going to be 484, or pretty darn close to it because we rounded. Okay. Last example, let's say a squared plus b squared equals c squared. Okay, now remember for a and b, let's locate the right angle. The two sides that are a and b have to be touching or adjacent to the right angle. And so that's going to be x squared plus 6 squared. Okay, and that's going to be equal to the c value. That's going to be across from or opposite the right angle. So that's going to be my 16, and we'll square it. Okay, so x squared, 6 squared is 36. 16 squared, I don't know that in my head. 16 squared, that's going to be 256. Okay, and so let's subtract off the 36. Okay, so 256 minus 36 is going to be 220. And of course, let's square root in our last step. So x in this case, 220, the square root of is going to be 14.832. And again, since we're rounding, let's approximate. And so like the eye check tells me this answer is probably pretty darn close. I know 16 is a hypotenuse, therefore the largest side, and so the number I get has to be less than that. Okay, even on the first one, the very first one, I got x to be 50. That was a hypotenuse value. That's going to be the largest of the three sides, and of course 50 is larger than both a and b. Okay, and so comparing sides even in that way, and we'll delve into that more as something called the hinge theorem was the way I was thinking about it, right? That's going to be a good way to kind of approximate to see if your answer makes sense, right? So without further ado, let's kind of do like a thinking wrap up on this. If I'm using the Pythagorean theorem, what are the easiest ways to quote unquote mess it up? Well, number one, choosing the wrong values for A, B, and C, okay? I did these examples for you, although my guess is if I said, hey, try these on your own, there'd been a certain percentage of you that would, for the second problem, would have written 10 squared plus 22 squared equals x squared, not thinking about what part goes where. That's really the mistake I see most often in the last 15 years of teaching geometry. By far, that's the most common error. Number two, order of operations. Yeah, just in the solving steps, not squaring first, maybe square rooting first, or just seeing some weird stuff. But you do want to solve your squares first. That's order of operations. And once you get x squared by itself, then you apply the square root. It's usually always the last step. And the third thing I think I see more often than not is just general arithmetic, just not squaring the numbers properly. Like suddenly 40 squared turns into 80 or something, or 10 squared turns into 20. So just pay close attention to the arithmetic. I know you're good at it. I know you can do it, okay? So that's a quick overview on the Pythagorean theorem. Let's move into using the Pythagorean theorem more as a tool. And so the Pythagorean theorem is interesting because even though it applies also only to right triangles, it then becomes a way to check if you don't have a right triangle, right? Let me try to explain what I mean. When I say classify triangles, and really that's what this is used to do, the Pythagorean theorem can classify triangles. What I mean is you can tell if it's right, obtuse, or acute. Okay? And I'm going to explain why, and hopefully you'll see this. But the Pythagorean theorem, in addition to finding side lengths, can tell you if you're looking at a right triangle, an obtuse triangle, or an acute triangle. Now, just in terms of review, if it has a 90-degree angle, we call it a right triangle. That's what we've been dealing with on the previous page. Obtuse means that you have an angle that in there that's larger than 90 degrees. And acute means that you have all angles that are less than 90 degrees or smaller than 90 degrees. Pictures are worth 1,000 words. And so when I talk about a right triangle, I'm talking about this guy, where of course the right triangle, or the right angle, excuse me, is going to be at the corner. The other two angles are going to be less than 90 by rule. If I have an obtuse triangle, okay, that means I have an angle that's larger than a sharp right-hand corner. It's wider. It's going to be like 91 all the way through 179 and some change. That's where that angle is going to be. And then if you have an acute triangle, all three angles are going to be less than 90. Okay? And all triangles can be classified in one of these three groups. So if you look at any triangle, you have to say it's at least right, or obtuse, or acute. There are ways to classify triangles by their side lengths, but these three classifications tend to be the most common and often the most important. Okay? So the Pythagorean theorem is going to help us do this. Allow me to demonstrate how. So we're going to kind of turn this into like an essential question. So if I show you this triangle, no matter how I have it drawn, is this triangle right? Is it obtuse? Or is it acute? Okay? And you can't look at the picture and just say, oh, look, it has kind of looks like it has a right angle. I'm going to call it a right triangle. That's not the way this works. You don't know that it's to scale. And so we have to have a calculation-based method to determine what type of triangle it is. Well, we don't have a Pythagorean theorem for acute triangles. And we don't have a Pythagorean theorem for obtuse triangles. We just have the Pythagorean theorem. So the way that we're going to attack this, in terms of this like finding steps, is we're going to assume the triangle is right. Okay? In other words, we're going to use the Pythagorean theorem. Okay? And so even though I don't know this is a right triangle, I'm going to apply a squared plus b squared equals c squared. And I'm going to use the same principles of the Pythagorean theorem. This looks like it should be the right angle. And so I'm going to take these two to be the legs of the triangle. This also fits because I know the hypotenuse has to be the largest side. And so I'm going to take 21 to be the potential hypotenuse. Okay, and so I'll take 13 squared plus 17 squared. Okay, and that's going to equal 21 squared. Okay, and so I'm going to put this into Pythagorean theorem, working on the assumption that it is indeed a right triangle. Okay, and so if I go to my calculator, 13 squared is 169. 17 squared is 289. And 21 squared is 441. Okay. If I take this left-hand side and I add it, 289 plus 169, I get 747, and that's matched up with 441. But wait a minute, if you look at the two sides, they are not actually equal. 747 is not the value I'm getting for c squared. This tells me right away, one, this is not a right triangle. Okay? If it was a right triangle, then a squared plus b squared would equal c squared. In other words, the left-hand side and the right-hand side would be the same value. But they're not. In fact, it's too small. Okay? And so we need to interpret that result. So let's do like a little thought piece. Okay, it should be 141. I'm sorry, it should be 747, but it's only 441. It's too small. And so here's what's actually happening. Okay, so you have. Let me actually draw it like this. So what you should have using the Pythagorean theorem is a right triangle like this, where you have A, B, and you have C. This is if everything had the same, or the right distances. But what's happening with your hypotenuse, it's not actually 747 like it should be. It's actually 441. It's like this. It's too small. And so to make a triangle, this actually has to angle in. Okay? And so if you look at this triangle, what we actually have is an acute triangle. Okay? It's not perfectly to scale, but you have to work with me on this, right? So because the hypotenuse is too small, this outside leg has to kind of bend in, right? And that makes an acute triangle. Okay, so if we extend that thinking, okay, if we run the Pythagorean theorem and c squared is too big, okay, let's run that same kind of thought experiment. So we should have, what's a right triangle? Okay, but let's just say we solved a squared plus b squared equals c squared, and we end up with a hypotenuse that's too large. So it should be here, but now it's out here. Okay? The only way to make this thing a triangle is to take this outside leg and to move it out to meet it. Meaning, this angle right here is going to be obtuse. Okay? Where this angle here becomes acute. Okay? And so what that means for us is that we can use the Pythagorean theorem as a tool to tell us if we have a right, obtuse, or acute angle. And so we assume the triangle is right. We use the Pythagorean theorem. Okay, we compare the c value to what it should be. In the case of this example, it should be 747, a squared and b squared, but it only became 441. Okay, in other words, it was too small. Okay, if it matched up, it would be right. If it's too big, it's obtuse, and if it's too small, then it's acute. Okay? And so it has everything to do with like the c squared value, whether or not it actually matches a squared versus b squared. All right, and so with that being said, we can now test this with all sorts of different triangles. Okay, so a squared plus b squared potentially equal to c squared. So for our first example, A and B have to be the smallest two sides because the legs are always the smallest two. So that's going to be 6 and 5. So 6 squared plus 5 squared. C squared must also always be the largest of the potential values because hypotenuse is also always the largest. And so that's going to be 8 squared. So if we solve this down, 36 plus 25 must equal 64. Okay, 36 plus 25 should be what, 50, 61? 36 plus 25. Okay, so this side is 61. okay, but it ended up being 64. Okay, so c squared is too big. Okay, it should be 61 to match a squared plus b squared, but it's too large. Okay, so what's happening? Okay, so we have a squared and we have b squared. Okay, c squared should be 61, but it's actually 64. And so what should have been our right angle is now extending. Okay, so this angle is now extending out to meet the longest side, the potential hypotenuse. And so this triangle is obtuse. Okay, so again, you see that we tested it just like a squared, b squared, c squared, the Pythagorean theorem. We ran it down. We see that we compare the two values, a squared and b squared, which is 61, to c squared, which is 64. They should match, but it's too large, which means the hypotenuse is shooting out past where it should be, so the triangle has to open up the right angle to meet it, hence obtuse. Okay, so even if we don't have a triangle picture, we can still apply this principle. Okay, now we just have to be careful in what we're choosing for A and B. Well, A and B are always the two smallest sides. It's adjacent to the right angle, therefore it's the smallest. And so we'll get a squared to be 12 and 35. That matches our largest side, 37. Okay, and now we now use arithmetic to compare. So 144 for 12 squared, 35 squared is 1225. Okay, and that's going to be equal to 37 squared, 1369. Okay, let's add our left-hand side. Let's add a squared to b squared, so 144 to 1225. That's going to be 1369. That actually matches exactly what we have on the right-hand side. So in this case, a squared plus b squared is equal to c squared. And so we know this is going to be a right triangle. Okay, and so again, just for the visual what's happening, we have a squared, we have b squared, and then we have c squared that matches it perfectly. It's not too short, it's not too long, it's just right. And yes, that's a corny joke, but that's actually how it helped me remember it when I was trying to learn this stuff. Okay, one last time into the breach. A squared plus b squared is equal to c squared. Oops, c squared, there we go. Okay, here they're trying to trick us, they're jumbling up the numbers. But we know a and b have to be the two smallest sides. So that's going to be 4 squared plus 6 squared. And that's going to equal the longest side, 7 squared, at least it potentially is going to be the longest side. 4 squared is 16, that's going to be 36, and that equals 49. So adding 16 plus 36, we get 52. So 52 is not equal to 49. Okay, in the same way that wasn't equal there either. Okay, so 49, it should be 52, but it's only 49. Okay, so that's going to be too small. Okay, if it's too small, that means it's going to be acute. Okay, and again, just so we have a visual of what's going on, okay, we have a squared, we have b squared in a potential right triangle, but c squared should be 52, it's only 49. Okay, and so even though there should be a right angle here, the side length has to kind of rock in to meet it, and that creates an acute angle here. Okay, so that's why I'm saying this is an acute angle. It's that angle that has to rock in. Okay, and guys, that's all there is to this. Okay, so if you're going to tell if it's right, obtuse, or acute, you work on the assumption, and let me scroll back up so you can see the steps. Okay, so we're going to work on the assumption that the triangle is going to be right. In other words, we're going to apply the Pythagorean theorem. We look at the c squared value compared to the a squared plus b squared value. If they're precisely equal, like they should, and that should be c squares here. Okay, so c squares. If they're exactly equal, then we know it's a right triangle. If c squared is too big, in other words, if c squared is bigger than a squared plus b squared, Okay, we call it obtuse, and if c squared is less than a squared plus b squared, that means c squared is smaller than it should be, hence it's going to be acute. And that's exactly what we saw here. And so here it should be 60. So in this first example, let me highlight, this number should be 61, but it actually is 64. It's larger than it should be, so it's obtuse. Here we have the two numbers being equal to one another. They're both 1369. If they're equal, then they're right. And here we have 49, and it's too small. It should be 52. It's only 49, so it's going to be acute. Okay. So let's do a quick summary. Now, obviously, if you didn't quite understand that part, go back and rewatch it. Let's do a quick summary here. Pause the video, take a second to write these out, and make a guess about what you think it should be in those blanks. And so if you're following along and you did those practices with me, hopefully you can figure that out. So pause, and then I'll give you the answers in 5, 4, 3, 2, 1. Look at that magic, okay? And so in summary, the Pythagorean theorem gives you the formula a squared b squared equals c squared, where a and b are either sides. They're also called legs, and c is also always going to be what we call the hypotenuse. You can always find the hypotenuse, yes, because it's the largest side, but really it's opposite of the right angle. Okay, and so if you have a right triangle, and you know where the right angle is, the hypotenuse should always be approximate, not touching. Okay, so hypotenuse is opposite of the right angle. Opposite means not touching. Where the legs, the two other sides that are not the hypotenuse, are always adjacent or touching the right angle. Okay, so these are legs. And then what we call adjacent. Okay, they're adjacent to the right angle. So the other way we can use the Pythagorean theorem is to classify triangles. In other words, determine if they're acute, obtuse, or right. In other words, does it have a right angle? Right. Does it have an angle larger than 90? Obtuse. Or does it have an angle smaller than 90? Acute. Okay? Or all the angles, excuse me, are less than 90. You start by assuming the triangle is a right triangle and apply the Pythagorean theorem, and then you compare. Okay? If c squared is larger, that's what that symbol means. Remember, if it opens up towards a number, that means it's larger than. So if c squared is larger than a squared plus b squared, that means c squared is too large of a value. That means it stretched the triangle. So you have the two legs, okay, but it stretched the triangle like this. Okay, hence obtuse. Okay, if c squared is too small, okay, it opens away from the c squared, and that means it's less than. There we go. That means it's too small, and the triangle is acute. Okay, so we have something more like this. Okay, that's not really a good acute triangle, but work with me on it. And so like this rule you should know is something we call the converse to the Pythagorean theorem. You probably didn't know that, so go ahead and write that in. The rule is called the converse to the Pythagorean theorem. Okay, and that just means we're not using the Pythagorean theorem in the normal way. We're using it in a different way, kind of backwards, hence the term converse. All right, guys, that's 30 minutes. Thank you for sticking with me. Thank you for taking these notes. You should be ready for the practice now. The practice is just a little bit Pythagorean theorem, reminding yourself how to solve it because you got to be good at that. And then there's some practice directly over if the triangle is acute, obtuse, or right. As I said in class, I'm not going to go over this in class. I'm not teaching a lesson over this in class. And if you ask me a question on this, the first thing I'm going to ask you to show me is that you completed the notes, completed the summary, and did the practice. So make sure you do that. I can appreciate that if you're not quite sure and you did all the practice, I can work with you, but you have to do your part first, and you all know it. All right, guys, that's it. Thank you for attending today's class and doing today's lesson. Have a wonderful rest of your Wednesday. Tomorrow we start trigonometry, which is awesome. It's my favorite thing. Have a wonderful day.